Assalamu alaikum everyone. Welcome to 100 Days Shrimp Farming Training Program organized by Tawakkal Fish Hatchery and Farms. Sorry for the little delay. I am Anisha Fatma, currently pursuing MPhil Fisheries and Aquaculture from the University of Veterinary and Animal Sciences, Lahore. And it is a great pleasure to welcome you all to another informative session of our 100 Days Shrimp Farming Training Program. This program continues to serve as a valuable platform for learning and collaboration, bringing together aquaculture professionals, researchers, and farmers from around the world. Each session provides us with new knowledge and international perspective that are helping to shape the future of shrimp farming in Pakistan. Before we begin, let us start our session with the recitation of Holy Quran. So I would like to request Mr. Muhammad Umar to recite some verses from Holy Quran. Jazakallah.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم والعصر إن الإنسان لفي خسر إلا الذين آمنوا وعملوا الصالحات وتواصوا بالحق وتواصوا بالصبر صدق الله العظيم.
Jazakallah. Now, without any further delay, let us welcome our host, Mr. Yuval Lat, all to our session of 100 Days Shrimp Farming Training Program. Sir, we are very honored to have you here, and we are very enthusiastic to get whatever your teachings and findings from your experience of 35 years.
Okay, can go ahead. I think from your side, right? You're going to
Okay, sir.
upload from your side. There.
Okay, sir.
I sent the new version, the edited one.
So I will share your presentation. Just give me a second.
It's dated with 16 October. I just sent it this afternoon again. It's a new version. So it's updated some of the corrections, right? Yeah. Please use that one. Okay, good evening, everyone. Before I like to start with the water quality management in the shrimp pond, can you go back to the slide number 7? That there were some errors yesterday. Yes, this one. This is about the zoning, and I was giving the some of the example of uncontrolled shrimp farming development outcome, disastrous outcome in Thailand, especially this is in the Ranot district, right, in the southern probably, yeah, part of Thailand. So this is you can see these graphics. So from the 2002 to 2015, they have conducted the survey. You can imagine that 2002 has already saturated the shrimp farming area in that district, right? See, almost 30,000 rai. So you can just convert it later on, divided by the 2.25 rai to an acre, right? So in that 2002, there are only 87 rai in the what you call it, abandoned shrimp farm. So both total area and the ongoing shrimp farming are the same, almost the same, right? Almost 99%. But in the 2009, it's much more saturated. It's oversaturated in the same district. So it's coming to from 29 to 31, 32,000. And then you can see here the red bar, the abandoned shrimp farm numbers increased to 6,542, right? So this is clearly stating that the environment cannot handle this much of the shrimp farming, right? So there are a lot of factors involved though, but what I like to mention is here, when it comes to 2015, it's already increased to from 31 to 35 again, almost 36,000. So here you can see the red bar increasing more than double to 16,000 right? So this is clearly showing how the zoning is important in developing the shrimp farming in any area, right? Okay, this is what I just like to add that it is already extremely oversaturated in this area, so it's coming, you know, a lot of failure in the shrimp farming. So it's ended up with like 16,000 of the shrimp farming area, which is you can see total area. It's like almost 50% of the total farming area become abandoned shrimp farm, which means they all lost, right? All they invested, whatever they have invested, everything lost because they are abandoned. They cannot grow anymore. They fail and fail and fail again. It's not sustainable. Thank you. Okay, let's go back to the water quality today. Okay, here today we will talk about them. Can you go back to the first one? I mean, the previous one, 24. Okay, we have to remember the theme here. Water is where the shrimp lives in. We have to remember that. Then if we remember that, and then we can think about how we create and maintain the water quality where the shrimps can grow well, live well, survive well, right? Next, please. This is how the water quality management is coming into important factor, right? So why do we need the water quality management in the shrimp aquaculture? Because there are several factors involved in that. And external factors is environmental impacts are quite serious. You can see in these the photos, some of the impacts are mentioned. And the land-based environmental pollution, flood water here, so it can be affected to the shrimp farming, and also the agriculture runoff and the domestic waste, right? Agriculture runoff has both pesticide and fertilizer nutrient pollution there, right? Next, please. And also the shrimp farm to shrimp farm in itself, right? Like a self-pollution impact is also coming from aquaculture or even from the shrimp farming. So water quality is deteriorating through the culture period, right? So we need to manage this water quality. If we just leave it, and then it will be unlivable for the shrimps, right? So when the water quality deteriorates, this poor water quality weaken the shrimp, and at the same time it promotes the pathogen growth, right? Different kind of pathogen. It could be parasite, it could be bacteria, it could be viral, right? These are not desirable for the shrimp culture. And also there is one main issue of the aquaculture effluent, right? The effluent has a nutrient load. There could be some chemicals in it, and also the microbes, right? All kinds of microbes. There could be a pathogen as well, or non-pathogen microbes as well. So they all are in the effluent, so we need to manage it. Manage means what? It is not just normal manage that we are going to talk about, but in the later on, I'm going to explain about what is the management in the water quality, right? Next, please. So in the water quality management in pond, we just have to remember these 3 points, right? The first thing is, I mean, not the 3 points, see, there are like 6, 7 points here I want to mention. The first one is the aquaculture principle. What is our principle in aquaculture? Prevention is better than treatment, right? So we have to focus on the preventive measures. And another point what we have to bear in mind is about the management information. The management information in managing aquaculture pond, especially or even in the water quality management in this case, mostly indirect. Whatever we got information about the pond, these are indirect. Why I'm saying this? Like for example, when you have like in the chicken farm, for example, you can see the chicken eating, but in the shrimp pond, you don't see the shrimp is eating because you cannot see in the pond to the pond bottom or in the water column, right? So how you will know whether the shrimps are eating well or they're not eating at all or they finished the feed or they're not enough. It's all indirect information you're getting. We get from the different indicators, right? Different apparatus and so on. So that we have to remember the water quality also some are direct and some are indirect. We will see more under the later part of this presentation about how this water quality is much more complicated than what we think, right? Another thing is the true information. We need to have a true information about the feeding, water quality, the shrimp health, the pond inputs, and the bottom. These are necessary. True information means it's true and correct. There are some information that are not correct. It's all not true information, maybe indirect, then we need to interpret correctly, right? So this is what I like to mention. The true information is necessary. If it is not true, if there are some error, then we got the problem in analysis, and then we got the different results, varying results, and we can make the wrong decision. So it will lead to the wrong decision, I mean, sorry. And another point I want to mention is monitoring or checking the water quality, right? We have to know where we have to check the water in the pond or in the tank. When do we need to check or monitor? How do we check the water? How frequently we need to check the water? Just once a day, enough? Or twice a day? Or thrice a day? How many times? And what parameters? Where are we going to do that? So these all are important. And another important point is interpreting the data. Once you got the data, this is just the data. Then you need to analyze and you need to interpret, right? What does it mean? You got this, for example, ammonia, this. You got the pH of this. What does it mean, right? Sometimes, like there are correlations. Then I'll explain in later on in this presentation. So, and then to whom you need to pass this information. Sometimes the monitoring water quality is another person, but managing the pond is another one. Especially in the medium scale or the large scale farming, there are maybe tens, dozens of ponds are there, or probably 50, 60 ponds or hundreds of ponds, thousands of ponds. Then we have somebody measuring the water quality, monitoring the water quality. Then they need to pass out this information to whom, right? That's a point. If one is not correct, right? Then we got anything, whatever you monitor. If one data is not correct, and that lead to a wrong data analysis, and you got wrong decision, that will be later on. It goes to chaos in the pond, right? And then another point we need to remember is the biomass increase. This is the principle, right? And we're talking about the principle here. The biomass increase daily. As long as the shrimps are growing, shrimps are being fed, so the biomass, the shrimp is growing its weight. So biomass is when it's all combined, all like 100,000 shrimp or 200,000 shrimp in a pond or whatever, or 1 million shrimp. So the biomass is increased. When the biomass increase, the waste increase. The produce waste from the biomass, from the individual waste. You have a different type of waste, and then it's increased. It become harmful. So we need to manage. Next, please. So now this is about the how many, like how we're gonna manage here and in the pond. There are mainly three groups in water quality management in the shrimp farm, right? The first one is the incoming water. We need to treat the incoming water. The second point is managing the water and the waste during the culture, right? Manage means all monitoring, controlling, treating, everything, adjusting. These are the management, right? And then another point is the effluent management. So you've got the effluent means is discharge water, right? Every day you are changing the water or every other day. So when you change the water, that we call it effluent. So you need to manage the effluent because the quality may be poor or very poor. So we need to manage in order to avoid the negative impact to the environment or even to the self pollution, right? So then we talk about management. Then I like to mention a little bit about the management. What is it, management? In this case, right? First, we have to get the information. This is how we get information from monitoring. We got the data, we analyze, and we got the information. So after getting the information, the next steps is action. We need to act based on the information we received, right? After that, we need to verify whether our act give us whatever we need. We aim to get, okay, we are acting to increase the alkalinity by applying lime. After that, we need to verify, check again whether this objective of this 100 ppm is achieved or not, right? We have to verify the information after the action. Then we need to maintain. Once we get it, once we achieve the objective, then we need to maintain the condition, right? This is what we have to do. Then after that, in the daily activity, we need to record. We need to enter, make the data entry. We need to analyze. Sometimes we need to analyze on a sit instantly. Sometimes we need to analyze in the free time for the next day, for the next week, for the near future. We need to analyze or keep on analyzing all the data and keep on planning ahead of the what is going to happen, right? So then after that, check against action, right? So which means that after you have recording, then you need to go through all this again, right? What you have done and what you have recorded, what you have got, the results is all have to check it out. And now I like to explain a bit more on the how do you treat the water if you don't know it is quality, right? So this is what I'm trying to say is the reasoning, justification of monitoring the water, right? If you like, I think I mentioned in the very beginning, about monitoring in the environment, in the water source. If you don't know the water source, how are you going to treat the water for the farm, right? So this is talking about the monitoring of the source water quality. If you don't know what is it, what is this water about, then there is no way that you can treat, right? Whether you need this chemical or whether you don't need this chemical. Like, for example, if the water is turbid, then you need to have a sedimentation pond. But if the water is very clear, you don't need the sedimentation pond, for example. So this is it, right? So it's all about the cost and the consequences. And the treat the water as per objectives. What do you want? What is your objective? You need the salinity of 15 or 20 or 35 or 10. This is your objective, right? What pH do you need? What DO do you need? So based on your objective, right, then you need to treat the water, right? Maybe sometimes you want to reduce the toxicity in the water. Sometimes you want to eliminate the pathogen, right? So these are the objectives, and based on the objectives, you have to act. So then after taking action, you have to check again. What result do you get it? If the results is not achieved what you are expecting or what you are planning, then you have to treat again. This is a point. I want to mention is also in the later part of this presentation, I will explain again. If this process is not there, you will have some problem. A lot of people miss this one. After doing, for example, okay, we apply 10 kilo of lime for this pond. What do you expect? To increase the pH, to increase the alkalinity. After that, if you don't measure, you don't know whether you want to achieve the pH of 8.2 or still 7.8. You don't know. You think that you apply the 10 kilo or 20 kilo of lime, then it will give you the increased pH or increased alkalinity. Actually, it is not. Then you have to do it again. If you don't know it is not achieved, then there will be a negative consequences. You just assume. This is totally wrong. So that we have to avoid this kind of thing in the management, right? And then next, please. Another one is the SPW, which is the short form for shrimp pond waste management, right? So right now I'm just talking about the water management and the waste management roughly, right? Then we can go on to the more detail, right? This is a summary about the shrimp pond waste, right? So there are 5 steps in the management of the waste. The first, we need to monitor, then we analyze about the waste, then we take action, right? In this case, I want to mention we have to be proactive action, not responsive. A lot of people, one of the takeaway here, I want to say that aquaculture has to be proactive rather than responsive. Responsive means when something happens, you are responding to that problem. For example, you got the low DO, or DO going down to 3.5. You want to act. That is responsive. You respond to the low DO. It is not good. It is dangerous in shrimp farming, especially in the intensive shrimp farming, because the quality and the condition changes very quickly when it is stocking density is very high. So you have to be proactive. The action must be proactive, which means before you get the lower, you have to act. How are you going to maintain this higher, or how are you going to maintain this current DO not to be lower, not to be dropping, and things like that, right? So then verify the outcome. What kind of the results you are getting, you need to verify whether, like I just mentioned in the water quality as well, whether you achieve your target, your expected target or not. If not, you have to act again. You have to modify, readjust, things like that. Then after that, you need to dispose this waste. How are you going to dispose, right? So this is, I mean, that we will see in the later part of this presentation about disposing the waste. So there are two types, you know, during the operation and after the operation and so on. So this is in the short about the process of the waste management in the pond, right? And now I'd like to explain about the SPW, Shrimp Pond Waste Management Regime. How, right? What are the before going how, then what is it about the SPW? What form we see that usually? There are metabolic waste. It's coming from the metabolism of the shrimp and also some other organisms. In the shrimp pond waste, we are talking about everything coming into waste from every input or every organisms or available or existing in the pond. It's not only shrimp. There could be some algae, right? There could be some parasite. There could be billions and trillions of bacteria. They all produce waste from their physiological function, right? Their metabolism, and we call it metabolic waste. And those wastes could be in the gaseous form. For example, carbon dioxide, ammonia, hydrogen sulfide, and so on. And there could be a solid waste. Solid wastes are like feces and the pseudo feces, sediments, you know, lime, feed waste, you know, dead animal, dead algae, plankton, you know, zooplankton or phytoplankton or whatever, you know, these are the forming into the solid waste. So these wastes has to be mapped out, right? So where they are, where the wastes are accumulated, where the wastes are forming, where the wastes are less, or whether there is no waste, right? You need to map out, which means that you take a little bit of a survey and then mapping out where they are and so on. So when you talk about this management regime, then we have three main regimes, right? Actually, this is four. I think I put it later on. It is a remove, reuse, and recycle. It is four actually, right? So, I will explain more detail later on, but this is just remember about this four first. Right? And also there is a different kind of the management regime. So we can act as a physical action or biological action or chemical, mechanical, you know, all different types of action to manage the waste, right? So different measure, different action. Thank you. So now we talk about the water quality management principles and objectives. What are those? What's the objectives? Right? So the act of the objective or the management principle here is to maintain the optimal water quality condition for the cultured organisms, which mean here shrimp, while its effluence is controlled as much as possible, right? So this is a water quality management. So another point is this condition that we require, that the shrimp require or the pond itself is required. You need to keep in the optimal situation because we want to reduce the disease risk. We want to promote the growth We want to reduce the negative effects. So this is the objective in the managing the water quality. So you have to remember when we do something, we also remember the principle and the objectives, right? When we manage the water, we use the HACCP principle, right? This, I think everybody knows about this. It's been introduced for, I think, more than 20 years or 25 years, I think, since early 2000, more into the agriculture, more and more. So, you know, the hazard principle, right? Hazardous analysis, critical control point, right? Critical control point. So that principle we are using in shrimp farming water quality management, right? So again, I want to emphasize here, prevention concept is based. In the very beginning today lecture, we have talked about prevention is better than cure, right? Or the treatment. So we need to prevent first. So prevention based or prevention concept focused here. And another point here we need to remember in the water quality management is the cost. We cannot use any management system or treatment devices or a system if the cost is too high, is beyond the production cost that we deem necessary, right? So if the cost is too high, why we have to use, right? We cannot use. So we have to maintain the optimal cost. At the same time, we have to adjust this cost and the implication. What if we use this regime, what will be the implication? Okay, cost is effective, but will it give to the positive results? What are the implicating factors? Is there any other implicating factors there? So we need to adjust this to mainly in the water quality management, right? Yeah. Implication to the shrimp, implication to the pond dynamics, and so on. Next, please. So now I like to talk about the underground water source. I think many shrimp farm in your area. I think most year is in Punjab, right? So my information. I mean, I have very little information because I haven't been to Punjab yet. I just I was in Karachi a couple of months ago, so I haven't been able to visit to Punjab area, right? So I think during my assessment a long time ago for the World Bank, I got information mostly the saline water for the shrimp farming is obtained from underground, right? So there could be an underground reservoir or things like that. Right? I have no idea. So I even don't know whether those were estimated and checked properly or not, right? So, but I have suggested at that time to conduct a proper survey on this. So we have two different type of in general, right? Two different type of underground water source. One is the inland saline water, and another one is the coastal seawater, also underground, right? But coastal seawater is more simple. But anyway, so in inland saline water, the salinity will be variable. It could be from 5 to 10, 15, could be. I don't know. It depends on the geographic location. Some of the salt rocks also have a very high salinity in some places in Southeast Asia as well. And usually the underground salt water are lower in the DO. And the pH, alkalinity, and the hardness will be totally varied. Because if they are passing through the lime structures, and then the alkalinity and hardness will be quite high, also the pH. But if it is not, if it is going through some of the laterite or some other things, then the pH will be lower. So we don't know. So we need to monitor first all the underground water quality. And sometimes in some region, they have arsenic, even coming into the surface well. Surface well is say about 5 meter deep, maybe, probably 3 to 5 meter deep water well. It can get some arsenic in the water, especially in Bangladesh. Some part of the Bangladesh, we can see some with the arsenic poisoning. So we don't know also here, maybe there are some substances aside from the arsenic, maybe some other heavy metal or something we don't know. So we need to have a complete water quality profile analyzed for the underground seawater in this place. So not yet. Can you go back to the slide, the previous slide? Yeah. So we need to monitor and the prediction. I mean, like, it is possible once we got the information, like the prediction is more possible because it is not changing much. Because if it is not the underground water, it's not the flowing water underground, then it is much easier to predict or what will be, right? And for the underground source, the chemical threat is more than the biological threat, usually, right? But in the seawater source, it's usually coming through the sand bed, right, in the coastal zone. It's not so far from the waterfront. So usually these are aligned with the sand layers, a few meters, maybe from a couple of meters to tens of meters. So when they are going through the sand, so in the coastal area, the BOD is reduced, so as the turbidity and the microbes also reduce drastically. So in that case, the chlorine requirement, if it is needed to treat, is very low, right? DO could be acceptable because only like, I think about 1 to 2 ppd different from the surface seawater and the underground seawater in the coastal area. And pH, alkalinity, hardness also mostly resemble to the main seawater body outside, right? And another one is the low plankton or almost no plankton. It could be some problem for some cultural system, but not always so, right? You can still introduce from other culture to plankton into the pond, right? And monitoring in the sea is also possible because it will directly link to the underground coastal seawater, right? Yeah. Next. So now I like to talk about the incoming water treatment approach, right? So as I mentioned, we need to know how we're gonna treat the incoming water. So it depends on the source, and then you have a different type of treatment, right? There are different approaches when you are going to treat the water. Some are like elimination of the organisms. Sometimes it's not. It's like organisms, all the organisms, all living things, they are eliminating. It's like using chlorine. Sometimes they are only eliminate the disease factor. So you have to know what are the disease factor for that specific region, and if the vectors is available, and then we have to eliminate, right? So the approach is not total elimination of organisms in the incoming water, but to eliminate the disease factor only. And another approach is to improve the water quality. If there is no disease risk, or if there is no the disease factor risk are there. It's nothing is there, just to improve the water, and then the approach is to improve the water quality, right? And sometimes it could be removing the undesirable organisms or substances, right? Some debris or some of the what do you call it, the fry or the eggs or lava, it could be there. So they need to remove those. Right. Next. Next, please. Yeah. So what kind of a treatment under the incoming water treatment regime, right? So we have a physical treatment, chemical treatment, and a biological treatment. So physical treatments are like screening, sedimentation, filtration, and a UV. These are all physical treatment, right? So chemical treatment is like everybody knows, right? It's a HOCO is a hypochlorite, right? So chlorine treatment. So we either use the chlorine or the KMNO4 permanganate or ozone or formalin or pesticides. It's kind of the pesticide, right? So in the chemical treatment, they're using all this kind of thing, right? But it's depend on where they are and what kind of the water and so on. Another regime is biological treatment. So in the biological treatment, we use usually the fish or sometimes bivalves, sometimes probiotics, depend on the water quality in the water source, right? So I will explain more later on about the biological treatment as well. Next, please. So in this case, I mean, treating the water, I think as physical is everybody knows what to do and has been doing that. Now we need to pay more attention in the chemical treatment that what usually most people do, right? So you have to remember approximately 3 to 5 ppm of chlorine can kill the most of the bacteria and viruses, right? Most pathogen. But of course, um, that again, this what is it? 3 to 5 ppm. I'll explain later on, right? And when you are doing this, one important thing to remember is the organic matter. OM is the organic matter. Is the water contain organic matter? What is the percentage? What's the load, right? If the organic matter is a lot in the water, then the chlorine you apply as a disinfectant will go to oxidize the organic matter first, and the remaining the chlorine will kill the pathogen, right? So if you have a higher organic matter in the water, then you will need the higher dose because your 3 to 5 ppm or 10 ppm may no longer enough to kill the pathogen if you have a higher loading of organic matter. So that we need to remember. A lot of people just fix it. Oh, we use 10 ppm, we use 30 ppm, 50 ppm, so on, right? Why? This is what I'm saying. You need to monitor the water first, incoming water quality. What is it, right? Do you have a higher turbidity or do you have the high organic loading or high plankton and so on, right? So that's the thing. And when you dechlorinate after the chlorination, you need to dechlorinate, right? So in that case, sunlight is the best in the dechlorination. Of course, there are strong aeration and so on, right? But the sunlight is very quick and you can remove in 1 day, something like that, depend on the dose as well, right? And also, right, as I mentioned, in the earthen pond, you need the higher dose, right? So because earthen pond has a lot more, what do you call it? It depends on the pond type as well, right? In this part of the Asia, the pond soil has more organic matter than and part of your area, I think. So it depends on the soil type as well. And when you calculate the chlorine, you need to have active ingredient. For example, you are setting up like 10 ppm chlorination, right? Your dose is 10 ppm, and that dose is not using the total the chlorine, what do you call it? When you calculate the weight that you need, then you have to look at the active ingredient contained in the product. So your chlorine powder has 60%, then you have to use that 60%, right? Then you calculate and compensate for that. The remaining 40% is not the chlorine, not the active chlorine. These are the fillers, right? You know, the filler to make it some form, right? So, and sometimes chlorine percents also vary. It depends on the brand, depends on the product, right? And the purity maybe vary. So that you have to check it out very well, right? Like you have to make a product QC, input QC, and so on. Whether the top layer of the container has 60% and the middle is only 40%, and the lower maybe 65 again. Someday it should be consistent, right? So your product need to be checked first before you use, right? And another point is the mixing, right? So a lot of people say that I apply chlorine, but there's still some disease coming up because the mixing chlorine in the water is very difficult, especially when they apply the powder form rather than the solution, right? So it's not well mixed in the pond, just using the Perowi aerator. Sometimes you need to use a submersible pump and the bottom layer mixing pumps and so on. You have to need a combination of the pumps to make the water as much as possible to mix 100%, right? And another point is you make the chlorine solution in the 500 or 1 ton tank or something, and then apply the lime water by the pump again. So then it could be much easier because even though it is a highly soluble chlorine, if you just get in the water and then start mixing, then the efficiency is decreasing, right? And after the application, then you go for checking the residue, right? Then you go for the dechlorination process and things like that, right? So I just mentioned also in the previous video. Next, please. So the maintenance, right? So when we treat the water, like there are chemical treatment, physical treatment, and the biological treatment, right? So this is one of the things that that I prefer also, and low cost and preferable. But of course, there's a degree of the varying degree of effectiveness, right? So using fish, right? Here in this case, I like to point out the tilapia. When you get with the polyculture, tilapia, and then you can have the fish as the treatment for your water quality or the waste quality improvements. You can do for both, right? So we use the tilapia here because the tilapia has 2 AMPs. AMP means antimicrobial peptides. That is available in the mucus system. The mucus can be in the body and the esophagus and also in the gill. There are a lot of AMPs, right? They have different AMPs, but tilapia has a specific AMPs that can trap bacteria and viruses, including the EMS bacteria and the white spot virus and so on, right? So that will reduce the pathogen load if you use tilapia, right? So when you culture the shrimp with the tilapia, polyculture, right? So at the same time, the tilapia can also reduce the waste loading and improve the waste quality, reduce the microbial load, and enhance the plankton and so on. Because we have like a biodivision. You know, I will explain later part also in the waste treatment, right? So tilapia make the nest, especially the May tilapia. it's by nature the males are making a nest for the female to spawn. So when they make the nest, so it's stirring up the sediment on the pond bottom. If it is the earthen pond, right? But in the um, plastic lined pond, also there are some sediment. I mean, but they deposit it, right? But it's much less than the other pond. So we call it biodivision. They stir up those, and then those stirred the shrimp pond waste are oxidized in the water column. So it's reduced the waste loading. Some of the toxic parameters like sulfide, ammonia, and things like that, they are reduced by this oxidation process, right? So they also convert the waste into the biomass. So they are grazing on the waste, I mean, either feed waste or some others, and then they convert into the tilapia biomass, right? So, but of course, at the same time, there are limitations in the use of tilapia, right? Because it's also consume some of the feed, but there are strategy to reduce, not to compete the shrimp feed and so on, right? And also the tilapia biomass, if it is a lot, also consume the oxygen and so on. But in monoculture, this is I'm just showing up with some of the comparative terms, right? So in the pre-treatment with the chemical means like chlorination or whatever, right? So it's reduced the pathogen drastically, but not 100%. You have to remember. Some people say that they what do you call it? We can reduce if they apply the chlorination 100%, but actually it is not, right? And the chemical disinfectant using during the culture, some people even do that during the culture in the very low dose, but it's still affecting negatively the shrimp health, right? And the mechanical and the biological and the chemical removal of the waste is required. So in the monoculture, and again the limitation in the chemicals and the equipment. So these are different from the polyculture because you got this, but in the polyculture they are continuous. It's going on automatically by the tilapia. Next, please. Next. So I'll just explain one slide. This is about the AMBs, right? This is Sidin. I mentioned about the two AMBs available in the tilapia. Here, Cyzidine and hepcidin, right? So it is in the Mozambiques, right? It's also in the hybrid tilapia. That's the saline tolerant tilapia because I have tested already. They can trap also. So they both are available. Next, please. So what do they do, right? So the EMS and a white feces causing fibrios. So it can be an PrEP inhibited by the cyzidine and the hepcidin, right? There's two AMPs. Here you see how they are effective. Here, the Vibrio parahemolyticus that cause EMS, right? Disease. Yeah, this is the Vibrio heavy, Vibrio agenolyticus, and so on. So these also causing like the white feces and so on, right? Next, please. Now, how do we measure, right? So it is about our water quality management during the operation, right? So it was the one I mentioned during the treatment, incoming water. Now it's getting more onto the, during culture operation, right? So we need to know what time, like I just mentioned previously, how frequently need to monitor, need to sample, and where, which location we have to do that. And how do we analyze the data, right? So then we develop the action in consideration of the other monitoring data. What other monitoring data we have? We have feed monitoring, we have a shrimp condition, we have a bottom condition, we have a shrimp pond waste quality, water availability, and so on. Based on these information, we need to develop the action, right? We have to consider all factors, all the information we attain, then how we gonna treat the water, how we gonna manage the water. It's not the simple one factor action, one factor based action. It is not that, right? Then after that, we apply the management action. Then we check the outcome, like I mentioned, that we have to verify. And if we need necessary adjustment, we have to go, right? Because whether we apply like 20 kilo of line, but it is enough. If it is not enough, if the outcome is showing not enough, then we have to adjust again, add or next time reduce, something like that. And we need to record all what we have done, right? All the data, all the information. So that will be a very good information for the father planning and treatment and the adjustment. Right? Thank you. Next. So I mentioned about the time and place. When do we need to monitor or check the water quality and where, right? So usually there is a, in a less intensive pond, there is a more diurnal fluctuation, which means the day and night fluctuation in the water quality is a lot more. But in the very high intensive, super intensive pond, so more or less almost the same. But of course, in sometimes the animal activities can also vary. So shrimps are more nocturnal, but at the same time, like I mentioned, when you have a super intensive, it's almost not not much difference, right? Also, in general, we usually measure in a two like in the morning 5 to 6, in the afternoon 2 to 3, or 9 to 10 p.m. in the night, right? We measure like DO, pH, blah blah blah. Like I mentioned here, hydrogen sulfide is very very important. A lot of people has been missing out since long time ago, right? Your ammonia can give you the trouble. This is hydrogen sulfide is more serious trouble. You have to remember. And now we are, in the past we go only up to this, right? But later on in the past 10 years, we are adding up like Tom and DBC and VBO load and things like that, right? So, but here, like I mentioned, this is a time that we need to measure. But how do we come up to this time? The most important thing is what time we can detect the harmful level, right? What is the harmful? For example, the hydrogen sulfide is the lowest in the morning when the temperature is lower. pH is usually lower in the morning, right? Then, because it's the cumulative effect from the night feeding and so on, right? So we think that 5 to 6 is the harmful level. Then we measure. So that's why I'm saying detect the harmful level that can cause the harmful level, right? Detect the time. Yeah. Also in the afternoon, we know that ammonia is directly correlated with the higher temperature and the higher pH, right? So the higher temperature could be in the afternoon. Maybe this region is 2 to 3 p.m., but another region, depending on the sun direction and so on, could be 4 to 5. So we have to change. We cannot fix this 5, 6 or 2, 3, and then 9, 10. You have to look at it where the time you can detect the most harmful level, right? And the time required to take the remedial measure. For example, you know that this is like 5 a.m. is the lowest, or 6 a.m. is the lowest DO, lowest pH, right? But remedial measure means you need the DO of 4.5 in the morning, for example, in the intensive farming. How long does it take to take the remedial action? I mean, the corrective action. It takes 1 hour, and you go 1 hour ahead, right? Then you predict again for the next. So in that case, you need the like a 3D cycle. You need the graph to predict for the next hour, right? How the water quality will be there in the next hours. So this 2 point will give you when you need to take the monitoring, right? Like that. You to determine also the place, right? Where. This is when, this is where. You have to know which place will give you the most poor water quality in the pond, right? If you are, a lot of people make the mistake. Many shrimp farms, many aquaculturists, many even big companies make the mistake. They usually measure the water quality in the bridge. You know, the feed trays where the feed trays are settled, right? Check at the same time at the edge of the bridge. They are checking the water quality. They are sampling the water from there. This is really ridiculous. I tell you why. Because usually those bridges are in front of the aerators, right? Whether we aerator or whatever, you know, like the air jets and so on. So the water quality is very good and the strong current and so on. So water is always good in those areas. So if you, your objective is to know the poor water quality, and then you are every time you check the water in the spot you're getting the good water quality. How do you manage? How do you know that you have a poor water quality? But in other place where there's a dead end or where there is a the whirlpool or something with a more sedimentation and then more the shrimps are gathering there, you got a more poor water quality, then you don't know because you are getting the information from the good place, good sampling location that give you the wrong analysis and the wrong decision making and wrong action. This is very important, right? The place and the frequency also the same, right? How frequently you need to monitor? Is it 3 times a day or 4 times a day or only 2 times is enough? Right? That's why I'm saying the 3D cycle you do in every month, right? In every certain biomass, then you can make the prediction from that. I can explain later on. Next, please. We already getting 1 hour, right? So, is there any question? What is next after this? Yeah, this is about the correlations, right? Yeah. Okay, go back to that. So, is there anything, or you want to go a little bit more, or you want to go tomorrow? What do you say?
Sir, it's
We
better
started
that
a bit
we
late.
move the assessment for tomorrow. Uh, if anyone has any question with one of the word noun expert, Mr. Yuan left, he can ask in question in chat box or you can ask personally from sir. He is one of the noun expert.
Hmm.
It's a great opportunity for all of us to learn from him with his experiences. Don't miss this moment and have your questions with sir.
Hmm.
Any participant, any confusion?
Are you talking to me?
No, sir. I am just asking
Uh,
participants if they
or
have
the
any question.
participant?
Yeah,
Okay,
yeah.
right.
Sir, your presentation was so detailed. Uh, Everything was mentioned with the calculations, and we are very uh, thankful to you for this piece of information that you specially made for our region, according to our, climate areas, and what are the things that are applicable to our region, Punjab. So you were asking, yes, South Punjab has many saline water areas. I don't know about Sindh, but South Punjab, now
Hmm.
here, Sarbarwala and some regions, there is shrimp farming currently. Mm. So nobody's asking questions, but I think when there will be last session, everyone will be just asking you a lot of questions.
Yeah.
They are not asking you now, but
Hmm. Okay, doesn't matter. Maybe we can
sir,
do
there is a
tomorrow
question.
after the end of the session, right?
Yes, sir. Yeah. So there's a question in a chat box. Which play function of phylogenetic and non-phylogenetic organisms in shrimp farming? Phylogenetic and non-phylogenetic organisms.
I think that the voice quality is not very clear here. Maybe can you send it by email?
Sir, this question is in chat box. You can see there.
Uh-huh. Uh-huh. Or if they can
Maybe they are asking for phylogenetic and non-phylogenetic organisms in shrimp farming.
what are those? I cannot hear probably. Let me see. Where is the chat box? Mm, I don't know where to go from there. I cannot read. Okay.
Okay, sir. Should I tell you the question if it's not in reach of you? So there is
Uh,
another question. Would you
mm.
explain the map showing shrimp farms and their density region-wise? Density region. They are asking about density.
Which density?
Maybe stocking density.
Shrimp farming. I mean,
Yeah.
you farming density or the stocking density in the pond?
Sir, I think they are asking about stocking density.
Stocking density.
Yeah.
I don't have a stocking density mapping. I think no one has it as well because every farmers has a different type of stocking density. So
Yes, sir.
it's difficult to answer this question.
So actually, they are asking about map which shows
Mhm.
shrimp farm. Uh, we will share a search presentation in the group. You can have that map from that presentation if you are more
Oh,
interested in that.
you mean the map I was showing in the
Yeah.
presentation? I can share
Yes.
this paper. I can share the paper, but it is it is in Thai. It's only the abstract is in English. That's why I made the wrong putting the date, so I recorrected from the yesterday. The year it is in a Thai like 2545, like 2558, and something like that. So that's a Thai calendar year. So
Yes.
I have to translate into the English calendar and put it there. But the paper is quite good, but it is in Thai.
Mhm.
I don't know. You can translate it and whether it give you the proper translation or not. I don't know, but I can forward it to you. All right, to Tawakkal and the Tawakkal can because I don't know any one of the emails and things, right? So can
So we can get translation. Not a big issue.
yeah.
Yes, sir.
You
Is there
can
any
you can
question
get
from
it.
any participant? So I think it has been 1 hour and most of the participants have left the
Hmm.
meeting, and so it was such an
Hmm.
comprehensive session.
Hmm.
I'm really honored to have you here. You are
Yeah.
one of the world-known expert, and getting from you is a honor. Thank you so much, sir.
You're welcome. I
Yeah, we
see
will share
the now I see the two question
yeah.
from Navina. Yeah, I think this is a very broad and very long question answer to like um,
It's a
this is a
biological
very
question.
broad one. We cannot
Biological.
answer right away. And also the map showing the shrimp farms and the density region wise. Well, if I can just forward that one, there are different type of studies about those mapping, right? I think there are a few in Indonesia and in Thailand as well, but I don't know. I'm not so. Yeah, there are some in India as well, but I'm not so sure how it is helpful because this land use changes pattern in the shrimp farming area. Some of the abandoned rice field becoming the shrimp pond. Sometimes the abandoned, but once it is abandoned shrimp pond, they cannot go back to agriculture because of the salinization, right? So this is a problem. But in the freshwater area, in especially in Thailand, some of the this is not really abandoned because they look at the economic efficiency of rice farming and the freshwater prawn farming, right? So because they have to buy the water, they pay the water in irrigated water for the aquaculture. So the what do you call it? Sometimes the rice price is higher, so they grow rice because the rice need less water, right? But sometimes at in the very dry season, the water is more expensive, the pumping water and the water cost, right? So they cannot grow freshwater prawn, right? So they grow rice. But in rainy or something, rainy season, they get much more plenty of water from the rain and things. So they grow the macrobrachia. So they are alternate farming, something like that. Depend on the cost and the profitability, that how far they can make it from each crop. So they choose that one, right? It's not really abandoning in some places, right? Yeah. But well, this is another area of a discussion.
Yes, sir.
So
So we are going to, yes, sir. Anything from you?
okay, we're gonna stop this, right?
Yeah, sir, we will continue it tomorrow if it's
Yeah,
comfortable
tomorrow.
for you.
Yes, we still have about 20 more slides, right? Yeah,
Yes,
because
sir.
we started also a bit late, maybe 10 minutes late. We started. Yeah. Anyway, someone is asking to share the PPT in a WhatsApp group. I don't know which one, which WhatsApp group.
Sir, we have a group
I
and we
think
will,
you can share it, right?
yes, sir.
My email is there as well, so they can reach if there are some questions, right?
Yes, sir, sure.
Yeah. Okay. Right. Thank you. Yeah. And bye
Once
bye.
again, thank you, sir.
Yeah.
Thank you everyone for your participation. And today's session is
Thank you,
about
everyone.